Paper 5. Planning, Analysis, and Evaluation. Paper 5 is a timetabled written paper focusing on the higher-order experimental skills of planning, analysis, drawing conclusions, evaluation. Paper 5 deals with Assessment Objective 3, where experimental skills and investigation are accessed. This exam will not require laboratory facilities. Paper 5 consists of 2 or more questions totaling 30 marks. Candidates may be required to design an experimental investigation of a given problem. Such questions may not be highly structured. Candidates may be expected to answer using extended, structured writing illustrated with appropriate diagrams, flowcharts, tables, or equations. Candidates may be asked to express a prediction in the form of a written hypothesis linking independent and dependent variables, or in the form of a graph showing the expected outcome. There may be questions in which candidates are given experimental data and are required to analyze, evaluate, and draw conclusions from this. Some questions may be set in areas of chemistry that are difficult to investigate experimentally in school laboratories, possibly for reasons of cost or safety. No question will require knowledge of theory or equipment that is beyond that expected of A-level practical work in the syllabus. Information that candidates are not expected to know will be provided in the examination paper. 5. Marks will be allocated for Paper 5, according to the following skills. Planning. This includes defining the problem and method, and takes a total of 12 marks. Analysis, conclusion, and evaluation. This includes dealing with data, conclusion, and evaluation and takes a total of 12 marks. The remaining 6 marks will be allocated across the skills in this grid, and their allocation may vary from paper to paper. Planning. Defining the problem. Candidates should be able to identify a safe and efficient procedure that when followed would lead to a reliable result. Identify the steps necessary to carry out the procedure. Identify an apparatus that is suitable for carrying out each step of the procedure. Show an understanding of the risks of a proposed experiment. Identify the independent variable in an experiment. Identify the dependent variable in an experiment. Express the aim of an experiment in terms of a prediction, and express this in words or in the form of a predicted graph. Identify any variables that are to be controlled. Show an understanding of how and why the procedure suggested will be effective. Method. Candidates should be able to describe the method to be used when carrying out the experiment to its full conclusion, including as appropriate preparation of results tables, proposed graphs to plot, key points to consider in any evaluation of the method and results, and reference back to the prediction. Describe the arrangement of apparatus, by use of words or labeled diagrams, and the steps in the procedure to be followed in order to collect all relevant data. Suggest the use of appropriate measuring instruments, so that the data are recorded to a suitable precision. Suggest appropriate volumes and concentrations of reagents. Describe precautions that should be taken to keep risks to a minimum. These include use of a fume hood for hazardous gases, the use of a face mask for hazardous particles, avoidance of naked flames for flammable materials, and wearing chemically resistant gloves for handling irritant materials. Analysis, conclusion, and evaluation. Dealing with data. Candidates should be able to identify the calculations and means of presentation of data that are necessary to be able to draw conclusions from provided data. Use calculations to enable simplification or explanation of data, including calculation of mean, percentage, and percentage gain or loss. Use tables and graphs to draw attention to the key points in quantitative data, including the variability of data. Analyze data to draw appropriate conclusions. Plot an appropriate graph from provided or calculated data, fulfilling the criteria for plotting detailed in the Paper 3 section on page 61. Plot a graph of y against x and use the graph to find the values of m and c in an equation of the form y equals mx plus c. Suggest appropriate axes from a range of data values. Calculate the percentage error of a measurement. Calculate quantities from raw data. Use the correct number of significant figures for these calculated quantities. Analysis, conclusion, and evaluation. Conclusion. Candidates should be able to draw a conclusion from an investigation, providing a detailed description of the key features of the data and analyses, and considering whether experimental data support the conclusion reached. Make detailed scientific explanations of the data, analyses, and conclusions described. Make further predictions and suggest improvements. Conclude whether errors in experimentally obtained data could be accounted for by a measurement error or by other factors. Analysis, conclusion, and evaluation. Evaluation. Candidates should be able to identify anomalous values in provided data, suggest possible explanations for anomalous readings, and suggest appropriate means of dealing with such anomalies. Identify the extent to which provided readings have been adequately replicated and the benefit of this. Describe the adequacy of the range of data provided. Use provided information to assess the extent to which selected variables have been effectively controlled. Identify and explain the weaknesses of the experimental procedure used. Suggest and explain the effect that a change in the concentrations of reagents or the conditions used for the experiment might have on the results obtained. Suggest the consequences that the incorrect use of apparatus might have on the results obtained. Explain that data that obey a line of best fit are reliable because there are no anomalous points. Comment on the validity of data with regards to their suitability to prove or disprove a prediction. Analysis, conclusion, and evaluation. Evaluation. Candidates should be able to identify instances where additional readings being taken during the experiment would be advantageous, in order to give a more comprehensive range of values. Draw together all available information to make judgments about the reliability of the investigation and the trustworthiness of its outcomes. Comment on the quality of data and state whether or not the data supports a prediction. Use evaluations and provided information to make informed judgments on the confidence with which conclusions may be drawn. Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, Geometry.